Welcome to this episode of Mrs. Mulvey's Math Movies. In this episode, we're going to talk about finding the dot product. You should have already read the lesson about finding dot products. If you didn't do that, please do that so you understand what a dot product is. In this video, we're just going to practice finding them. There's actually two different ways to calculate the dot product. The first method you use when you have your vectors in component form. The second method is the method that you use when you're given the vectors in magnitude angle form. So let's take a look at the first method, the method that we use when we have vectors in component form. And we're going to find the dot product between the vectors 3, 4, and -2, 5. Here's a quick representation of what those vectors would look like. There's 3, 4. Remember, the vector is the segment that goes out to that point. There's the vector 3, 4. And here's the vector -2, 5. So to find the dot product, what we do is you look at your x values, and we're going to call this vector A and vector B. So you just separate the vectors out into two vectors, vector A and vector B. And the formula that tells us to find the dot product, see where the dot product gets its name, you multiply the x values. So this is A sub x and this is B sub x. This A sub x and B sub x is just a way of saying the x value from the A vector, and then B sub x is the x value from the B vector. The 4, the y value from the A vector, we call A sub y, and the 5, the y value from the B vector, we call B sub y. And so the formula tells us that we multiply the x values, A sub x times B sub x, in this case that's 3 times -2, and we add to that the product of the y values from each vector. A sub y is 4, B sub y is 5. So I follow my order of operations, I multiply, then I add. And so the dot product of positive 3, 4 and -2, 5, dot product of those two vectors is 14. So once again, you simply multiply the x values, multiply the y values, and then add. And that's all there is to that method of finding the dot product. Let's try one more. This time we're going to find the dot product of -2, 7, and -3, -9. So you can label these A sub x, A sub y, B sub x, B sub y. Or you can just think that you multiply the x values. In this case, the x values are -2 and -3. You multiply the y values, 7 and, -9. Let me get that negative in there. There we go. And you add them up. That's how you find the dot product. So this would be 6 plus -63. That gets me a dot product of -57. So now let's look at the second method of finding the dot product. This is the method that's most efficient to use when you're given vectors in magnitude angle form. For example, if I tell you that the first vector, I'm going to call it vector A, has a magnitude of 5 and a bearing of 20 degrees, and vector B has a magnitude of 9 and a bearing of 70 degrees, we calculate the dot product this way. you multiply the magnitude of A. Remember, this does not mean absolute value of A. This means the magnitude of A times the magnitude of B times the cosine of the angle between them. The key is to find the angle between those vectors. And for that, you need a sketch. And so I'm going to draw vector A first. I'm just going to give myself a quick east-west line and then a north-south line. So vector A has a magnitude of 5 and its bearing is 20 degrees. Remember, bearing is measured from due north in a clockwise direction. And so vector A, magnitude means the length of the vector, it's 5, and this angle in here is 20 degrees. Vector B has a magnitude of 9, so it's a little bit longer than A. In fact, you know what? Let's make it a different color so we can distinguish between the two. And its bearing is 70 degrees. That means from due north to this vector is 70 degrees. So to find the angle between them, that's this angle right in here. Just highlight it there. There we go. That angle in there, it would be the 70 degrees from there to there minus the 20 degrees, or the angle between them would be 50 degrees. And so when I apply the formula, I take the magnitude of A times the magnitude of B times the cosine of the angle between them. And then I simply take out my handy-dandy calculator, make sure I'm set to degrees, I am, and I multiply. 5 times 9 times the cosine of 50 degrees. I get my answer of about 28.93. So I'll just give the squiggly approximately 28.93, and that's the dot product of those two vectors. The key is to set up a diagram to be able to find the angle between the vectors. Sometimes you're going to have to subtract to find that angle. Sometimes you're going to have to add. So let's look at one where we need to add. If you want to write this example down, go ahead and pause the recording while you do that, because I'm going to erase what's up here now. So let's find the dot product of a vector with a magnitude I'm going to call vector A and tell you that it has a magnitude of 10 and a bearing of 20 degrees. So starting very similar to the last time, 20 degree bearing. This time though, vector B has a magnitude of 15 and its bearing is going to be 290 degrees. So when you go to draw it, one more time, you give yourself an east-west line and a north-south line. So the first vector, vector A, has a magnitude of 10, bearing 20 degrees. So from due north, measured in a clockwise direction, I go 20 degrees. And this measurement is 10 for its magnitude. For vector B, though, and let me just label this one vector A. For vector B, its magnitude is 15 and its bearing is 290 degrees. And so when I measure from due north, 290 degrees, from here to here is 90, from here to here is 180, from there to there, well, from here to here is 90, then another 90 makes it 180, and then another 90 to there. We're at 270 degrees now from due north. I need to go another 20 degrees to get to 290 degrees. So this angle from due north all the way over to here is a measure of 290 degrees. That leaves me right in here with a measure of, so remember, full circle is 360 degrees. I've used up 290 degrees. That leaves me with 70 degrees for this angle. So this time the angle between the vectors is 90 degrees because this one goes from there to there. That's a 20-degree angle. This opens 70 degrees. Together, that opening between those two vectors is 90 degrees. And this had a magnitude of 15. Now obviously this is not drawn to scale because vector B will be longer than vector A. But now that I know the angle between them is 90 degrees, I can use this formula that says to find the dot product, it's the magnitude of A times the magnitude of B times the cosine of the angle between them. And the angle between them in this case is 90 degrees. Now you may or may not remember that the cosine of 90 degrees is 0, which would make this whole thing 0 because 0 times anything is 0. But just in case you didn't remember that, cosine of 90 degrees is 0. To get your calculator and do 10 times 15 times the cosine of 90 degrees, and double checking to make sure you're in degrees. I am. And there I get my answer of 0. And so the dot product of these two vectors equals 0. So those are the two methods for finding dot products. Let me know if you have questions. Bye-bye.